Alright, hey guys, this is the video for the Activity 13-15 quiz review that I said I'd send out to you guys. So, what I'm going to do in this video is just go over every single problem in the review. Okay, I know you can, my answers are on Blackboard already, so if you want to look at those too, you can and follow along with those as in the video. You can do that as well, or you can just watch the video and check your answers that way. Okay. So remember, I gave you all the properties right here for quadrilaterals. I have kite, trapezoid, isosceles trapezoid, parallelogram, rectangle, rhombus, and square. Okay, I'm not going to read those out loud right now. You can read those yourself. If you need me to explain any of those, shoot me an email. Okay. Also, I've got the 4 theorems you need to know: triangle sum theorem, exterior angle theorem, triangle mid-segment theorem, and the trapezoid median theorem. So I give you these theorems for a reason, because these theorems are what allow you and what help you to solve the problems that are on this review. Okay, so let's begin. Let's look at number 1. Number 1 says draw a triangle XYZ with an exterior angle at the vertex Y. Okay, so every triangle has 3 vertices. Our vertices are here in this triangle are X, Y, and Z. Okay, so first I'm going to draw a triangle. And I'm drawing a triangle with an exterior angle. Remember what an exterior angle is: just an angle that is formed by extending one of the sides of my triangle. So I'll go ahead and draw that. Okay, got this. And then for my third side, I'm going to take this side and I'm going to extend it out a little bit like that. Okay. All right. So now there's a certain way I want to label my triangle, because it wants this exterior angle to be at vertex Y. So the only thing that matters is that Y will be right here. Okay, that means that vertex right here is Y. So this is important because there's going to be on the quiz, there will be an like a question that doesn't have a picture drawn for you, and it'll use kind of some of this same or similar terminology. Okay. So what are the remote interior angles that are corresponding to the exterior angle? Alright, so remember, remote interior angles are the the interior angles that basically are not touching the exterior angle. So if this is my exterior angle, the 2 remote interior angles, we can just name them, say they're angle Z and angle X. I actually think, I'm looking at my key right here, I put angle Y. It should be angle Z and angle X on my key. So hopefully you see that. That's my mistake on my key. Sorry about that. Okay, so let's look at number 2. Triangle MKL is an isosceles triangle with segment MK congruent to segment ML. If MK is 7x minus 15, KL is 4x minus 5, and ML is 10x minus 42, find x and the measure of each side. Okay, so first thing I'm going to do when I do these, I like to draw out my triangle first. Okay, it just kind of helps me solve it. I know it's an isosceles triangle, so I know 2 sides will be congruent, and those 2 sides that are congruent are MK and ML, based on what we're given in the problem. So I'll mark them like that, and I know if I'm going to have MK and ML. So that means that my vertex angle is M, and then we can put a K and we can put an L. Alright, so I know that MK is 7x minus 15, ML is 10x minus 42. Since those are congruent, we can set those 2 lengths and those expressions equal to each other. So as of right now, we're not doing anything with KL. Alright, so 10x minus 42 equals 7x minus 15. Okay, so this will give me 3x is equal to 42 minus 15 is 27. So I got this 3x by doing 10x minus 7x, and then divide both sides by 3 to get x is equal to 9. Okay, so that's part of our answer. Now let's start with finding MK. What we'll do, we'll just plug in 9 for x. So 7 times 9 minus 15, and that's equal to 48. Alright, MK and ML are equal, so ML is also 48. And then KL, lastly, 4 times 9 minus 5, which is 31. Alright, that's that. Number 3, triangle ABC is an isosceles triangle with AB and BC being congruent. AB is 3x plus 41, BC is 8x minus 54, and AC is 12x minus 103. Okay, find x and the measure of each side. So draw a triangle again. Alright, I know that AB and BC are the ones that are congruent. We know it's isosceles, so it looks like that. And then since my two sides have B in common, that's going to be my vertex angle. So this is A and this is C. Or it could be the other way around, either way. Alright, so AB and BC are the ones that are equal this time. So technically, look, if you're given something like this, you don't even really have to draw the triangle, because if I know this, I can know that automatically that this AB and BC will be equal. But if it helps to draw the triangle, please go ahead and do it. So BC is 8x minus 54. That's going to equal 3x plus 41. Okay, so subtract 3x from both sides, and we will, as soon as this stops being blurry, and I will add 54 to both sides at the same time. 5x is equal to, so 41 plus 54 is 95. So x divide by 5 on both sides, so x is equal to 19. Okay, now, similar to the last problem, we're going to find all of our sides by plugging in. So AB is equal to 3 times 19 plus 41. So AB is just equal to 98. So AB and BC are the same, so BC is also equal to 98. And AC is just 12 times 19 minus 103. So it equals 125. So guys, with these, we are finished. We found each side. So somebody with these two problems, 2 and 3, may be tempted to add those three expressions up and set them equal to a 180. But do not do this. No. Do not do this, because we're dealing with sides right here. And sides are just segments. We do not add segments up to equal 180. We can only add angles up to equal 180. And that is that's what the triangle sum theorem tells us. It doesn't say the sum of the measures of sides. It says the sum of the measures of angles. So do not do that. Please, please, please do not do that. Alright, moving on. Try to move a little quickly because there's so many problems in this video and I don't want it to be too long. Alright, triangle GHI is an isosceles triangle with these two sides being congruent. If GH is 3 more than X, so 3 more than X is GH, I is 17 less than 4 times X, then GI is 45 less than 6 times X. Okay, so what we're going to do here, we have to first figure out in terms of math what these are saying. So GH, we said, was 3 more than X. That's really just X plus 3, right? HI, 17 less than 4 times X. So it's 17 less than whatever 4 times X is. So it'll be 4X minus 17. Okay? And then GI, 45 less than 6 times X. So similarly, 6X minus 45. Alright. Triangle, isosceles triangle, I is the vertex, angle G and H. We know that because of this right here. So GI, which is 6x minus 45, is equal to 4x minus 17. Okay, we solve. Subtract 4x from both sides, we get 2x. Add 45 to both sides, so 45 minus 17 is just 28. So that leaves us with x equal to 14. Alright, so plug in what we need to find. So GH is just 14 plus 3, which is 17. Let's see. Let's do HI. HI is 4 times 14 minus 17, which comes out to 39. So that means that GI is also 39 since they are congruent. Awesome. Next, 5. Solve for x and find each angle measure. So what I'm given here is a triangle. Then I have expressions for the 3 interior angles of a triangle. The triangle sum theorem tells me that the sum of the measures of the interior angles of a triangle is equal to 180. So basically what I do is add the 3 measures up, set it equal to 180. Okay, so I can do that to set up an equation for x. So my equation will be 9x plus 3 plus 5x minus 2 plus 11x minus 21 is equal to 180. Alright, so 9 plus 5 plus 11 gives me, so 9 plus 11 is 20, and plus 5 is 25x, and 3 minus 2 minus 21, that is a total of negative 20, so minus 20. And that all equals 180. So add 20 to both sides, 25x is equal to 200. So divide 200 by 25 to get that x is equal to 8. Okay, so plug in to find these measures now. Angle D is 5 times 8 minus 2, which is 38 degrees. This one, 11 times 8 minus 21, which is 67 degrees. And then third one, 9 times 8 plus 3 is just 75. And of course we can check to make sure they all add up to 180. If you add those three together, you can check yourself that way, and they do. Okay. Number 5, solve for x, then find each angle measure. So I notice that I have an exterior angle right here, which is represented by 18x minus 15. And then I have two other angles, angle A and angle B, that aren't touching my exterior angle. They are what we call, remember, the remote interior angles, okay? So we do have a theorem that would make this problem a lot easier to solve. You could do something else, but this is the easiest way to do this, okay? The exterior angle theorem, if we remember, it says that the exterior angle is equal to the sum of the two remote interior angles. So it's equal to the sum of the two angles that it does not touch. So my equation for this one, using the exterior angle theorem, would be 18x minus 15 equals 13x minus 11 plus 4x plus 1. Alright, okay, so guys, use this theorem. Know the exterior angle theorem. It helps out so much. Okay, it saves you time, and it's just a good shortcut for finding the answer to these types of problems. Okay, so let's solve for x now. I'm going to clean up the right side. So I'm going to leave 18x minus 15, and I'm going to clean up this. 13 plus 4x is 17x. Negative 11 plus 1 is negative 10. Okay, so subtract 17x from both sides. We get x, because 18 minus 17 is 1. Add 15 to both sides. We get that x is equal to 5. Alright, now what I want to do is plug in to find my angle measures. Okay, 13 times 5 minus 11 is going to give me 54 degrees. 4 times 5 plus 1 is going to give me 21 degrees. And then 18 times 5 minus 15 will give me 75 degrees. And you can check to make sure this works, of course, by adding up 54 and 21, and what you will get is 75. That is our answer. Okay, moving on. Now look at this one. We have another exterior angle if in a triangle right here, so I'm probably going to use that exterior angle theorem. But what's different with this one is that these two angles, my remote interiors, they are equal. Okay? That's what that little hump means. It means they are equal. So I can still use the exterior angle theorem. I just know this is 7x plus 2, and this is what? Also 7x plus 2. Okay? So I can just say that 17x minus 23 is equal to 2 times 7x plus 2. Alright, and then that gives me, let's distribute the right side to get 14x plus 4. And then let's solve for x now. Okay, so I'm going to subtract 14x from both sides to get 3x, add 23 to both sides to get 3x is equal to 27, so x is equal to 9. And that's all we were wanting to find for that one, so we're done. 7. This we're finding x and y. Again, we have an exterior angle, okay? So I notice that my exterior angle is in terms of x, and then one of my remote interior angles is in terms of x, and then the other one is just a number. So if I use the exterior angle theorem, I'd have an equation with just x that I could use to solve for x. So let's do that. Use exterior angle theorem. So 9x plus 4 is just equal to 4x minus 7 plus 86. Okay. We simplify this a little bit now. 9x plus 4 is equal to 4x plus 79, because 86 minus 7 is 79. Alright, subtract 4x from both sides to get 5x. Subtract 4, this will give me 75 on the right. So x is equal to 15. So I found x. Now, two different ways to find y. You can either, actually I noticed that the way I'm going to do it is I'm going to show that the interior angle right here is 7y minus 1, and then my exterior angle, we know they're a linear pair. So that means they add up, add up to 180. Okay, so what I'm going to do, let's plug in for x in the exterior angle, and that'll give us a number, and then we can set up an equation for y. So 9 times 15 plus 4 is equal to 139 degrees. Okay, so my equation for y will be 7y minus 1 plus 139 is equal to 9. It's equal to 180. Okay, so simplify 7y. This is just 139 minus 1, so it's 138. That's equal to 180 still. Subtract that 138 from both sides. We get that 7y is equal to 42. So 42 divided by 7 is just 6. And we're finished. Alright, next. Number 8. In triangle MNP, if measure of angle M is 4x minus 3, measure of angle N is 9x minus 6, and the measure of angle P is 6x minus 1, find x and the measure of each angle. Alright, this tells me nothing. This tells me that all I have is a triangle, and I know the expressions for each angle. That's all I know. I don't know if it's isosceles. Nothing tells me that. I don't know if it has an exterior angle. Nothing tells me that. Okay, so all I know is I have three angles that are inside the triangle, and I know they're inside the triangle because it's M, N, and P, which are the vertices. So I know that you can, by the triangle sum theorem, you can add up the three angles in a triangle and set them equal to 180, and that's what we're going to do to solve for x. So 4x minus 3 plus 9x minus 6 plus 6x minus 1 equals 180. 4 plus 9 plus 6 is 19x. Negative 3 plus negative 6 plus negative 1 is negative 10, is equal to 180. So 19x, when we add 10 to both sides, is equal to 190. So of course x is just equal to 10. Okay, plug in to find the rest of them. Okay, measure of angle N is just 9 times 10 minus 6. 90 minus 6 is just 37 degrees. Okay, measuring angle P is 6 times 10 minus 1, so 60 minus 1 is just 59 degrees. And then measuring angle M, 44 times 10 minus 3, 40 minus 3 is 30. This is not 37 degrees, excuse me. I was looking at my key. Instead of 37, this is 87. Oh, 84, guys, excuse me. Looking at my key and messing myself up. That's 37, that's 84. Sorry if I confused you with that, okay? So, don't make these quick mistakes and careless mistakes like I'm making, okay? Take your time with this, and you'll do just fine. Alright, number 9. Find DE. Alright, so let's look at this triangle right here, okay? I noticed that these two segments on either side are congruent, and then the same thing for this side. What that means is that E is a midpoint, and then D is a midpoint of that side. Okay? What is drawn between, if you draw a line between the two midpoints of sides of a triangle, then you have a triangle mid-segment. Okay, I have expressions for DE and AB, so we'll use the triangle mid-segment theorem. Okay, I also noticed that those are parallel, and that's another thing that we know about the mid-segment theorem. But the main thing we want right here to be able to solve for x is I know that the third side, this AB, is going to be half. DE, the mid-segment, is half of whatever AB is going to be because it's the third side. So my equation, instead of doing, I can say that 2 times DE, which is 4x plus 1, is equal to the third side, which is 11x minus 25. So 8x plus 2 is 11x minus 25. So subtract 8x from both sides, add 25. 27 is equal to 3x. So x is equal to 9. And find DE now. DE is the mid-segment, right? So 4 times 9 plus 1, 36 plus 1 is 37 degrees. Not degrees, just 37. Okay. Awesome. Moving on. If MN, NO, and MO are mid-segments, alright, see that? I'm probably using triangle mid-segment theorem. Find the perimeter of triangle JKL. Alright, this one. All I'm going to do is use the triangle mid-segment theorem a few times, and then I know perimeter is just all three sides added up together. Okay? So that's what we'll do. Okay, so let's start off with the numbers that we can find that easily. MN is a mid-segment, and JL would be the third side for that one, so I can just double whatever 49 is, so that's going to give me 98 for JL. And then similarly for KJ, we will just double 42, because NO is the mid-segment. So 42 times 2 is 84. One easy way to spot this, which one I need to be doubling, or which one, how they're alike and compared, is we're always going to be looking at the parallel sides, right? Because they are parallel based on the mid-segment there. So that's an easy way to see which one you're looking at. Okay, so for our last one, I know that to set up an equation to solve for x, I know that similarly to how I found those other two sides, I can say that 2 times 6x minus 1 is equal to 13x minus 10. So 12x minus 2 is equal to 13x minus 10. Subtract 12x, add 10, so x is equal to 8. Right? Yes, x is equal to 8. So that means this side KL is 13 times 8 minus 10, which is 94, I believe. Yes, that's what it says, 94. So my perimeter is just 84 plus 98 plus 94, which will give me 276. Next, in the following quadrilateral, if the following quadrilateral is a kite, find all the missing angles label. Alright, so what you need to do is look at the properties of kites, okay? I know that if we look at on the review itself, I'm not going to go there, but I'm looking at it on my key. So you could go ahead and do this as well. Look at the property number 3 on the review for kites. It says that one diagonal divides a kite into two congruent triangles. That's this one right here, the dotted line that I'm about to trace out, okay? That gives us two congruent triangles. So what that means is that this top triangle is it's congruent to the other ones. It means that it's kind of flipped over. That means it's very easy to find the angles knowing that, okay? So that means that 1 and 2 will be the same. 7 and 57 is already, I can know it's 52. So I'm going to write them out first. So I know that 7 is 52 just because of what property 3, knowing that they're congruent triangles. It's also, you can think of it, another one, property 6 tells us the same thing, okay? So I found 7 is 52 degrees. So 5 and 6 are going to be equal, so whenever I find either one of those, I know that both of them. Alright, 4 is just 65 degrees. So I know angle 3, let's see, property 2 for kites tells me that diagonals are perpendicular. So perpendicular lines form right angles, so measure angle 3 is 90 degrees. Okay, now let's find, since I know 4 is 65, I know 3 is 90. Let's do 180 minus 90 is 90, right? 180 minus 90 is 90. Okay, so I'm left, all I really need to do is subtract 65 from 90 to get the measure of angle 2. Or you can do 90 plus 65 is 155. Subtract that from 180. You'll get that the measure of angle 2 is equal to, where's all my paper? Measure angle 2 is equal to 25 degrees. Okay. So that means the measure of angle 1 is also 25 degrees. So the measure of angle 5 now, okay? Similarly to what I did, I subtracted 65 from 90. Do the same thing for this right triangle. I know this is 52, so 90 minus 52 will give me the angle 6, since this is a 90 degree angle. 90 minus 52 will give me, what is it, 90 minus 52 on my paper. It is 38 degrees. So if I know that, I also know angle 5, which is 38 degrees. And with that, we're finished with that problem. Okay? Not as bad as you think it is. We have to use the properties of kites to be able to do some of these, though. Okay, you'll be using these properties a lot to solve these problems. I told you, that's why we give them to you. All right, number 12. We also have another kite, number 12. Okay. I know in a kite, property 5 tells me one pairs of opposite angles are congruent. Okay. So obviously K and M are not congruent. One's way bigger than the other, so it has to be these two that are congruent in this kite. So all we need to do for this one is set them equal to each other. 8x minus 31 is equal to 5x plus 23. So 3x is equal to 31 plus 23 gives me 54. Then divide 54 by 3 to get that x is equal to 18. So we're finished. We are not. We want to plug this in to find the measure of angle L. So it's 5 times 18 plus 23. And then put that in your calculator or solve that. It gives me 113 degrees. And we're finished with that one. One more kite problem. So for P13, look at property number 6. It says one diagonal bisects one pair of opposite angles. Okay, so we have our two diagonals drawn. IG is one of them. It obviously, those two angles right there are not congruent, so we know that's not the diagonal that's bisecting those angles. But these look pretty equal to me, right? So it's this this diagonal is bisecting those two angles, which results in them being equal or congruent, so we set those equal to each other. 5x minus 1 equals 2x plus 11. 3x is equal to 12, so x is equal to 4. Now we want to find FGJ. Okay, so, which is this angle right here, FGJ, so I'm trying to find that angle. So notice I just have a little triangle right here, right, with a right angle in there, okay? So if I plug in to find this angle, let's do that first. So 2 times 4 plus 11, 8 plus 11, that's 19 degrees, okay? I can just subtract 19 from 90 to find the angle I'm trying to find. So the measure of angle FGJ is equal to 90 minus 19, which is 71 degrees. Awesome. 14. Down to trapezoids now. Alright, weird. I've given two angles in a trapezoid. So let's look over our trapezoid properties first. I automatically see that number 2 says, on my review, number 2 says the lower base angle is supplementary to the upper base angle on the same side. Okay, so remember, my base angles are the angles, you take one base and the angles that are formed with that base and the legs are your base angles. So this would be, say, a lower base angle, and then a upper base angle on the same side would be this one right here. Okay, angle M and angle 87 degrees they add up to 180 because they're supplementary. Okay, so I can say I know that the measure of angle M is just going to be 180 minus 87, which gives me 93 degrees. Similarly for the other side, this is just going to be angle K will just be 180 minus 51, which will give me 129, I believe. Yes. And that's that. Easy as can be there, okay? But you have to use your properties to know that. If you would have read your properties, that would have told us that, okay? And that would also kind of need to know where the base angles were. But if I looked on my notes, base angles, it shows where the base angles of a trapezoid are. Okay, number 15. All right. For trapezoid P, Q, R, S, Y, and Z are midpoints of the legs. That means that this line drawn from Y to Z, called YZ, is a median, triangle median, a median of a trapezoid. So that means I can use the trapezoid median theorem. Okay, trapezoid median theorem tells me that this 2 times this base, or this median, is just equal to the sum of the two bases, which are PQ and SR. Okay, so with that, I can set up an equation to solve for x like we need to find. So 2 times 5x minus 19 is equal to 38 plus x plus 14. So 10x minus 38 equals to 38. Or so 38 plus 14 will simplify that to give me x plus 52. Subtract x from both sides, add 38 to both sides to get that 38 plus 52 is just 90. So x is equal to 10. And then we want to plug that in to find yz. 5 times 10 minus 19. 50 minus 19 gives me 31 degrees. Alright, so for this one you had to know that the midpoints are what makes a median. Okay, so that's from our notes, and then you need to use you have to know the median theorem to find this, the trapezoid median theorem, excuse me. Alright, this one, 16. There's no words, all I'm saying is to find ML, but everything is in the picture on this one. These two are equal, so N is the midpoint of that side. These two are equal, so P is the midpoint, so of course NP is a median of the trapezoid. Okay, this is a trapezoid because those two the bases are parallel by those lines that tell us that. So using the median theorem, I know that 3x plus 11 plus 10x minus 12, adding my two bases, is equal to 2 times the median, which is 45. So 13x, 11 minus 12 is negative 1, so this is equal to 90. Okay, add 1 to both sides, 13x is equal to 91. So x is equal to 91 divided by 13, which is 7. Okay, find ML, plug in 7. 10 times 7 minus 12, 70 minus 12 is just 58. That's that. Alright, let's look at some of these property questions. So you need to know your properties because I'm going to ask you questions like these, not necessarily these in particular, but questions that make you think about the properties, okay, of quadrilaterals. So you need to know the properties. Which quadrilaterals always have opposite angles that are congruent? So I'm actually going to go up to the properties right now. Which quadrilaterals have opposite angles that are congruent? Alright. What this is really asking is that which quadrilaterals have two pairs of opposite angles that are congruent. Okay, I want all, what they mean by that is that all opposite angles would be congruent. Okay, so because there are only two pairs of opposite angles in a quadrilateral. So look at kite. Kite only has one pair of opposite angles, so it's not that. Okay, or angels as it says here. Trapezoid. I see nothing about angles being congruent here. Okay, we know base angles, but not opposite angles. Base angles are, of course, consecutive, not opposite. Parallelogram, opposite sides. Ooh, opposite angles congruent. Awesome. So it's a parallelogram. All right, I can stop here because I know that it's a parallelogram. Okay, if that's the case, that parallelograms have opposite angles congruent. We know that rectangles, rhombuses, and squares are all parallelograms. So they also all are going to have opposite angles congruent. So I don't even need to look. I know my quadrilaterals that will have that will be parallelogram, rectangle, rhombus, and square. It's a very neat and nifty thing to remember, okay? All rectangles, rhombuses, and squares are parallelograms. So if we know a property works for a parallelogram, then it automatically has to work for those three as well, okay? Which quadrilaterals always have diagonals that bisect opposite angles? So if you look back at your things, I'm not going to go back up there, but if you look at your properties, you see that kite has one pair of angles, opposite angles that are bisected by a diagonal. Okay, not both. Okay. Let's see, trapezoid, I don't see anything on that. Parallelogram, no, I don't see that either. I see diagonals bisect each other, but not the opposite angles. Rectangle, do not see that. What I do see is that a rhombus, it works for that. Okay, a rhombus. Okay. And we also know that every square is also a rhombus, so this is a square as well. Which, if you look at my key, I conveniently left that off. It is also a square, okay? That's my fault. Which quadrilaterals always have diagonals that are congruent? Okay, diagonals that are congruent, okay? So, kites do not. You can, if you need to, you can draw out a kite and even just see that. If you only want to look at the properties, draw out a kite. Obviously, that one is much shorter than the other one, so nope. Okay. How about a trapezoid? No, because trapezoid look too weird for that even to can look super weird for that even to be the case. Okay. Parallelogram. No, that one's obviously much shorter than that one. Same. It looks like a rhombus is going to be the same thing because those kind of look kind of similar. Nope, not congruent. The diagonals will not be congruent. How about a rectangle? Yes, they look pretty congruent to me. You can check this by looking at the properties, and the property of a rectangle does say diagonals congruent. So rectangle. A square also, because a square is a rectangle. so it has to be true. And then last one, what if we had an isosceles trapezoid? So I said a regular trapezoid wouldn't work. It's not always true, but in a isosceles trapezoid, which means the legs are congruent, we also have the diagonals are congruent. So that's cool. Wasn't expecting that. Isosceles trapezoid. So my best thing, if it asks questions like this, the easiest thing for me to do is to just draw out the figure and then draw it and see if what it looks like, okay? All right, which quadrilaterals always have consecutive angles that are supplementary, okay? So what I mean by this, I'm meaning that all consecutive angles are supplementary. All of them are supplementary, okay? So let's look at a kite, okay? Are all my consecutive angles going to be supplementary? I do not believe so. I do not believe so. Nope, they are not supplementary. Kite does not have consecutive angles supplementary. At least I don't think so. No, okay. The reason they don't, they look like it's not easy to tell from the picture. I'll tell you that one, okay? But the reason I know it's not, because look, what if we said those two angles are supplementary? If we said those were supplementary, then if we looked at the other two consecutive angles and looked at these two, we know that these angles that are across from each other are not congruent. So there's no way that both of those could be supplementary. So that means a kite does not have consecutive angles supplementary. Trapezoids are so weird. We know trapezoids though. Trapezoids, the only consecutive angles that are supplementary are the two types of base angles. So like these and this and that, okay? But those two are not supplementary. All right? So the base angles are not supplementary to themselves, to their other base angle. So not that, so it's not isosceles trapezoid either. And then, how about parallelogram? Let's look at that. If you look at the properties of parallelogram, it is true actually. These two are supplementary, these two, and these two are supplementary. So it's parallelogram, and that also tells me that it's rectangle, square, and rhombus as well. Okay, I'm abbreviating now so we can kind of get through this quick. Which quadrilaterals always have diagonals that are perpendicular? Okay, let's check out the kites. Yes, so kite. How about trapezoid? No. Okay, if you find one example that doesn't work, then it's cool. We can say it's not. How about parallelogram? Nope, they don't look perpendicular at all. Even if I drew them quick, they're not actually. So, rectangle. Nope. How about rhombus? See, rhombus almost looks like a kite. It could be if the kites, they look very similar, but they're not the same. So rhombuses do have diagonals that are perpendicular. And then, to say square is a rhombus, they must also have diagonals that are perpendicular. Which quadrilaterals always have diagonals that bisect each other? Okay, a kite, they have one that bisects the other, but the other doesn't bisect the other one, so we cannot say that's true. A trapezoid, it's not true for. Okay, it's true for a parallelogram. That's one of the big properties of parallelogram. So if you look at the properties, it says that. So if it's true for that, it's also true for rectangle, square, and rhombus. Awesome. Moving on, let's do some rhombuses and parallelogram stuff now. All right, find the measure of angle GJK. All right, this is a rectangle. I don't say it, but it is a rectangle. Okay. That means, if you remember from in class, we know that all of these four lines in the middle are congruent. Okay. If you remember that, go look at our notes from that activity. Okay. We know that. So I have 4 isosceles triangles in here. Okay. So I know that these two are these two angles are congruent. These 2 angles are congruent. Okay. And I also know, actually, I don't even really need that because look, I know that this triangle right here and this triangle right here are going to be congruent because they have all the same side lengths, right? Okay, that is actually enough for us to know that. So cool, I know that. So this angle and this angle are congruent. Okay, another way to think about it, we have a transversal cutting 2 parallel lines. Alternate interior angles are congruent. So that's another way to think about it. Okay. So all we have to do is set 7x minus 16 equal to 5x plus 8. So 2x is equal to 16 plus 8 is equal to 24. So x is equal to 12. Alright, to find what we're trying to find GJK right here. So this angle, okay? I know that this angle plus this 7x minus 16 angle together, they form a right angle. Okay, so let's find what this angle is first. The one with the x. Plug in 7 times 12 minus 16 will give me 68 degrees. So the measure of angle GJK is just 90 minus 68, which is 22 degrees. Okay. You know, this video is getting kind of long, sorry. 21, solve for x. Okay, so again, these are all the same. Okay, this is an isosceles trapezoid, so these are both 5x plus 7. I can find this angle by doing 180 minus 134 because it's a linear pair. Or also realize that 134 is just an exterior angle of this triangle, right? Okay, that's what I'm going to do. I'm just going to use the exterior angle theorem. But you can also do the linear pair, get this angle, and then find that's the vertex angle of an isosceles triangle, and you can do it that way. So by the exterior angle theorem, though, which I realize here, I can say that 2 times 5x plus 7 is just equal to 134. Okay, so solve for x. 10x plus 7 is equal to plus 14, excuse me, 134. I actually solved this one different in my notes too, on my key, but that's alright. 10x is equal to 134 minus 14 is going to give me 110. Alright. Oh no, 120, excuse me. Can't do math. So x is equal to 12. And that's all we want to find. Alright, this one, 22. Find measure of angle XZW. XZW. So this angle right here we're trying to find. Okay? But I gotta find, if I found this angle that's represented by x plus 20, I can then find XZW by adding them up and set it equal to 90 degrees. So remember, we know in a rectangle these are all equal, okay? So that means this is also x plus 20, and then this is also 5x minus 8, because those are both isosceles trapezoids, and those two also add up to 90. So if I find this angle, it'll be the same as what XZW is actually, okay? So let's add them up and set them equal to 90. 5x minus 8 plus x plus 20 equals 90. 6x, 20 minus 8 is 12, positive 12. Subtract 12. This is equal to 78. So x is just equal to 13. Okay, so you know that since I said that the measure of XZW was just the same as whatever this would be, 5x minus 8. So 5 times 13 minus 8, which comes out to be 57 degrees. Awesome. 23. If PQR is a parallelogram, find the values of x values of x and y. Okay. So let's do x first. Okay. So I know in a parallelogram opposite sides are congruent. So set them equal to each other. 19x minus 9 is equal to 13x plus 15. 19 minus 13 is 6x is equal to 9 plus 15 is equal to, where am I at? 9 plus 15 is equal to 24. Okay, so x is just equal to 4. Now for these, the angles we have right here for y, these two are consecutive angles. Consecutive angles in a parallelogram are supplementary, so we add them up, set them equal to 180. Okay, 10y plus 14y, it's 4 plus 4y is 14y. Negative 37 plus 7 is negative 30, is equal to 180. 14y is equal to, add 30, give me 210. Divide both sides by 14 to get that y is equal to 15. And we're finished. (24) For this parallelogram, if NS is 2x plus 7, okay, and SQ is 5x minus 23, we know those are congruent, okay, because the diagonals bisect each other, so we can set them equal to each other. We found this is equal to 10, so NQ is just 2 times, say, NS, right, since they're equal. So it's equal to 2, then NS is 2x plus 7, so 2 times 10 plus 7 is equal to, 2 times 10 is 20 plus 7 is 27, so 2 times 27 is equal to 54. Next, I have another parallelogram here. Find out the measure of KLH is 134. So this whole thing right here, let me do that in another color. That's equal to 134. Okay. Now, you might think that these two are equal, but we don't know that. We don't know. They would be equal if the diagonals were they would be equal if, yes, they would be equal if the diagonals bisected those angles. But so I don't know that. I just don't know for sure that they're equal, okay? But what I do know, since this is a parallelogram, I know that the alternate interior angles, since it's a parallel, so two parallel lines cut by a transversal, the alternate interior angles are supplementary. Excuse me, not supplementary, they are congruent. So this is 4x plus 9. This is also 4x plus 9. Okay, so, and then I know that these two angles together are going to add up to this angle right here, right? Okay, and then I know from there, so we can say that this angle H, whatever is this, is just 4x plus 9 plus 25. Okay, but I also know, ooh, I did that wrong in the key. Goodness gracious, I did that wrong in the key, did I not? Wow. I am so sorry, I did that wrong. Okay, so in my key, don't pay attention to that. Pay attention to what I'm doing right here, okay? So these two consecutive angles right here, these two angles are supplementary, so I can add 134. When I do that, it's going to be equal to 180 degrees. 180 degrees. Okay. So what I'm going to do, let's see. Let's simplify a little bit. 4x plus 168 is equal to 180. 4x is equal to 12, so x is equal to 3. Okay. Whew. Do not look at my key for that one. That one is incorrect. X is equal to 3. So for this one, how do we want to do this one too? I know ABC is 115. Okay, so this whole thing, 115. Okay, and then remember we said that alternate interior angles whenever you have two parallel lines cut by a transversal. So this is also, this angle right here is 6x minus 11. The whole thing is 115. So those two add up to 115. Okay, 4x plus 6 plus 6x minus 11 equals 115. So 10x, so 6 minus 11 gives me negative 5. 10x is equal to 120. So x is equal to 12. Find the measure of angle ADB though. Okay, ADB is this angle right here, which is represented by 6x minus 11. So 6 times 12 minus 11 is 61 degrees. Okay. Alright, and that's it, guys. Sorry for almost taking an hour for your video, but that's your Activity 13-15 review. If you have any questions on that, or if you need a little more explanation, because I know I kind of went quick since we have so many problems here, email me and I can try to explain it a little bit more, okay? Good luck studying for your test, and I will see you all tomorrow.